Let's take a moment to remind ourselves of how to calculate certain areas. For a rectangle, it's just base times height. So this would be 5 times 3, which would be 15, and the units would be feet squared. We would multiply the feet by the feet. For a triangle, you would multiply the base times the height and cut that in half. So the area would be 1/2 times 4 inches times 6 inches, which would be 12 square inches. The hexagon here is a little trickier. You have a way to think about it where there's 6 equilateral triangles, each with a side length of 3 feet. So 3 feet with this height, which turns out to be 3 root 3 over 2 for the height, we would get that the area is 6 times the area of these triangles, because there's 6 triangles. So 6 times 1/2 base times height. And what does that come out to? Well, let's see. 9 times 6. 27 over 2, 27 root 3 over 2 square feet. So we have geometry formulas that let us calculate the areas of certain familiar shapes, and we can even break less familiar shapes into pieces that are familiar shapes, calculate those areas, add them up. But what if we wanted to calculate the area under something like a parabola? There's never been any formula we learned in a geometry class to do that. So for now, we're not going to get an exact answer. We're going to get an estimate. And the way we're going to estimate is using equal partitions and rectangles. By equal partitions, we mean we're going to consider the interval over which we're calculating this area, and we're going to partition it into equal pieces. We're going to cut this into equal pieces, and we're going to form rectangles using function values as heights. So if I were going to do that with, say, 4 rectangles, how might I make rectangles to fit under this shape? Again, if we're talking about equal partitions, we take this interval from 0 to 2, cut it into 4 equal pieces, which means each piece of this interval, each subinterval, is 1/2 wide. And then we consider a rectangle that's going to have height related to function values. In other words, we're going to pick some function value based on an x value somewhere in this subinterval and use that function value as the height. And right now I'm just kind of picking randomly. I'm picking a random x value to plug into the function to give me a y value. And I'm using that rectangle to estimate the area under this parabola. And you notice, these x values I picked were kind of random, kind of all over the place. I didn't really have a system for how I figured it out. But what I could do then, using these randomly chosen x values, is I could use the heights of these rectangles to calculate the area of each rectangle, add it up, and that'll give me some sort of reasonable estimate for the area under the parabola. But you can see that I'm in some places overestimating, and in other places I'm underestimating the area, meaning I'm missing part of the area. How do I know if I'm overestimating too much or underestimating too much? How do I know?